Now yesterday I have explained about the elasticity and stress and strain. So depending upon the deformation produced in the body, there are three types of stresses: longitudinal stress, volume stress and shearing stress. Longitudinal stress is produced in thin wires. When their length is increased, then longitudinal stress is produced. While the volume or normal stress is produced when there will be the change in volume of the body, and shearing stress will produce when there is the change in size of the body, change in shape of the body. Size will remain same, shape will be changed. Now corresponding to the deformation, depending upon the type of deformation, there are three types of strains. If there is a change in the length, then there will be longitudinal strain. If there is the change in volume, then there will be volume strain. And change in the shape, then there will be the shearing strain. Now what are the formulae of the longitudinal stress? What is formula of longitudinal stress? So stress means force upon area. Here force is acting normal to the cross section. Deforming force is acting normal to the cross section. Here also deforming force which decreases the volume, it is acting normal to the surface. While here force which brings change in the shape is acting tangential to the surface. Tangential to the surface. It's clear? And in equilibrium within the limit of elasticity. Already I have told that restoring force will be equal to deforming force. Within the limit of elasticity, what is the within the limit of elasticity? If on removing the deforming force body regains its original shape and size, then it is within the limit of elasticity. Every body is elastic up to a certain value of deforming force. That maximum value of deforming force up to which the body remains elastic is called the limit of elasticity. If the deforming force exceeds to that value, what will happen? Body will be permanently deformed. Body क्या हो जाएगी? Permanently deformed हो जाएगी. So in equilibrium, RF is equal to dF. So what is the formula of longitudinal stress? Here F upon A. F upon A. In every case, it will be F upon A. But here, since there is a change in volume, so we write it as small p. It's clear. Here, it is also F upon A. Here, force is acting tangential to the deforming force is acting tangential to the surface. Surface के tangential act कर रहा. Therefore, restoring force will also be tangential to the surface. Now longitudinal strain. What is the formula of longitudinal strain? Strain means it is the fractional change in the dimension of the body. Fractional change in the dimension of the body. So in case of the thin wire, dimension is decided by the length of the wire. Dimension is decided by the length of the wire. So what will be longitudinal strain? It is the change in length upon original length. Sometimes we write small l upon capital L. Volume strain. Since here volume is decreasing on applying the force, therefore change in volume will be minus delta V. We will not write delta V, we will write minus delta V because there is the decrease in volume. So it will be minus delta V upon original volume. And here shearing strain. What is the shearing strain? It is the measured by the angle by which the vertical surface is tilted in the forward direction, in the direction of the deforming force. It is the angle by which, suppose this is any body, here deforming force is acting in this direction. What will happen? Because of this surface is fixed. This surface is fixed. So what will happen? These surfaces, they will be tilted in the direction of the force. It's clear. So by this angle we measure shearing strain. shearing strain is theta. It's clear. And since this angle is very small, therefore theta will be equal to tan theta. And if you use this triangle, then tan theta will be equal to what? It will be equal to this length upon this. This is the x and this is the capital L. So it will be x upon capital L. What is x?
Displacement.
It is the displacement of the upper surface in the direction of force. Displacement of the movable surface in the direction of force. What is capital L? It is the perpendicular distance between movable surface and fixed surface. It's clear? So up to here I have explained. Now there is one Hooke's law. So what is Hooke's law? You can see here. Now all of you see Hooke's law. You write down. All of you write down. Within the limit of elasticity, you write down. Within the limit of elasticity. Within the limit of elasticity, stress is directly proportional to strain. Stress is directly proportional to strain. Now what will be the unit of strain? Unit of strain, yes. There will be no unit. Why? Because it is the fractional change in the dimension of the body. This is the change in length upon original length. Meter upon meter. No unit. Here volume, change in volume upon original volume. No unit. It's clear? Theta is already dimensionless quantity. It's clear? So within the limit of elasticity, stress is directly proportional to strain. Therefore, the ratio of stress and strain, stress upon strain, this ratio will be constant. This ratio will be constant. Ratio of stress to the strain will be constant. And this constant we call as the coefficient of elasticity. Coefficient of elasticity. Denoted by the symbol E. Means what is coefficient of elasticity? E equals to stress upon strain. E equals to stress upon strain. Now all of you see here. E equals to stress upon strain. Now we will see what will be the unit of stress. Stress का फार्मूला F upon A, force upon area, unit. What is unit of force?
Newton per meter square.
Newton per meter square. Newton per meter square. What is the unit of strain?
No unit.
There is no unit. Therefore, what will be the unit of this? It will be Newton per meter square. Newton per meter square. What will be the dimensional formula? Newton means MLT minus Newton means MLT minus 2. Meter square means here L square. So when you will simplify, it will be ML minus 1 T minus 2. So all of you note down. Now, depending upon the type of deformation, there are three types of coefficient of elasticity. There are three types of coefficient of elasticity in your course. One is Young's modulus. Young's modulus. This was given by Thomas Young, therefore it is known as Young's modulus. What is the meaning of modulus? It is the coefficient. It is the coefficient. It's clear? Young's modulus denoted by capital Y. It's clear? Then there is the bulk modulus. Bulk modulus. Bulk modulus, it is denoted by B. And third is modulus of rigidity. Modulus of rigidity. And it is denoted by the Greek letter eta. How will you make it? You will make like this. Eta. Greek letter eta. So depending upon the three type of deformations, there are three type of coefficient of elasticity. Young's modulus, bulk modulus and modulus of rigidity. Now what is Young's modulus? So Young's modulus is calculated for the thin wire. Now see here, this is a wire which is suspending from a rigid support. Its original length is L. Original length is L. Now when you have suspended some weights, here this body has been suspended whose mass is M. Whose mass is M. So it will set up how much force on the wire? This body will set up how much force on the wire equal to its weight. What will be its weight? Its weight will be equal to mg. Means what will be the deforming force here? Deforming force will be equal to mg. It is acting on what cross section? It is acting on this cross section. It is acting on this cross section. Because of this, what will happen? Its length will be increased. Its length will be increased. Suppose the increase in length is small l. Increase in length is small l. Means length is increased by this small l. Itni length is increased. It's clear. And when length is increased, when the cross section moves from here to here, cross section moves from here to here, restoring force increases from 0 to mg. Restoring force will act in what direction? Restoring force will act in upward direction. Restoring force will act in upward direction. Yesterday I made the diagram. While the deforming force is acting in downward direction. Deforming force F is acting in, this is the deforming force which is equal to mg. It is acting in downward direction. In equilibrium, both will be equal. When you remove the deforming force, what will happen? Now only restoring force is acting upward. What will happen? It will bring back this cross section up to this position. It will once again bring back this cross section to this position. It's clear? So see here, what will be the here longitudinal stress? Longitudinal stress will be restoring force upon the area of cross section. Longitudinal stress will be equal to restoring force upon area of cross section, and restoring force is equal to mg. Means what will be stress here? Stress will be, it is equal to stress upon strain, or you can write it as longitudinal stress upon longitudinal strain. Longitudinal stress upon longitudinal strain. So what will be longitudinal stress here? F, area of cross section is A. What will be strain? Change in length upon original length. So this, when you will simplify this, so y equals to F upon A. into capital L upon small l. Capital L upon small l. What is F here? Mg. F equals to mg. Means this is the formula of phi. You note down this. F equals to mg. What is capital L? Capital L क्या है? Original length. Small l change in length. A is what? Area of cross section. What will be the shape of wire? Cylindrical. Shape of wire is cylindrical. Therefore, if you take radius of the wire as small r, then it will be pi r square into small l. It's clear? If we take the radius of the wire as small r, what is small r? Radius of wire. How will you determine the radius of wire? By which instrument you can determine the radius of wire? Screw gauge. We can determine the radius of wire by screw gauge. So this is the formula of Young's modulus. Y equals to mg into capital L upon pi r square into small l. Now after this, bulk modulus. Now here this is a spherical body whose volume is capital V. Now if we apply force uniformly from all the directions, force uniformly from all the directions, this force has been applied. Capital F force has been applied uniformly from all the directions. What will happen? Its shape will not be changed, only the size will be changed. It will be slightly compressed. It will be slightly compressed. कुछ compress होगी, बहुत अधिक नहीं compress होगी. It will be slightly compressed. Now see here, compression mostly takes place in liquids, mostly in the liquids and gases. Gases are highly compressible. Gases are highly compressible. And why they are highly compressible? Because there is a very large intermolecular distance. Intermolecular distance. And a very small intermolecular force. It's clear. So here volume becomes V minus dV. Since there is a very small change in volume, so we write it as minus dV. You can write V minus delta V also. Now see here, what will be normal stress here? Here it is F. Let the area is capital A. Area of this sphere is capital A. So what will be the stress? Normal stress. Normal stress upon normal strain. Normal stress upon normal strain. What will be normal stress? F upon E. Strain will be change in volume upon original volume minus dV upon D. But already I have explained that F upon A is what? It is the pressure. It is the pressure. It is the pressure which is acting upon it. Extra pressure which is acting upon it. Extra pressure means other than the atmospheric pressure. Other than the atmospheric pressure. So see here, it will be equal to what? F upon E you can write as P. In denominator it is minus dV upon V. When you will simplify, it will be P into capital V upon dV, and here there will be minus sign. This is the bulk modulus. This is the bulk modulus. Now after this there is the modulus of rigidity. Have you noted this?
Yes.
modulus of rigidity. Now here this is a body which is in shape of cuboid, which is in the shape of cuboid. Its lower surface is fixed. इससे फिक्स किया जाए फेविकोल. Why it is fixed from the फेविकोल? So lower surface is fixed, but you can fix by some other way also. So lower surface is fixed. Now if you apply the tangential force upon it, means force is applied in this way. Force is applied tangentially to the surface. Deforming force is applied tangentially to the surface. What will happen? This vertical surface, it will become slightly slanting. It will become slightly slanting. अपनी बुक में फोर्स लगा के देखेंगे यही हो जाता है. It will become slightly slanting. Now the upper surface has moved, therefore a restoring force will act upon the upper surface in this direction. Restoring force will act in this direction. Deforming force is yes. What is the relation between both within the limit of elasticity? In equilibrium, Rf will be equal to Df. Which means let the area of this surface is A. Area of this surface is A. Then how much will be the stress? Stress will be equal to, this is equal to shearing stress upon shearing strain. What will be the stress here? F upon E. And what is the strain? Strain is measured by this angle theta. So it will be equal to theta. So eta equals to F upon A theta. This will be the eta equals to F upon A theta. And how can you measure theta? Theta will be equal to this length by which the upper surface has moved divided by its perpendicular distance from the fixed surface. Theta equals to x upon capital L. Now in the next lecture we will explain about stress versus strain curve.